Welcome back. In this submodule, we're going to discuss trigonometry and the context of periodicity. So we'll get some idea of what that means, and we'll use it as a tool to help us plot basic trig functions. So the basic idea is the following. If I turn 360 degrees, I end up exactly back where I started. That is, a rotation of 360 degrees is the same as a rotation of 0 degrees. In general, if I have some angle theta and I add 360 degrees to it, this gets me exactly back to where I started. So in some sense, these are the same angle. To talk about this in terms of radians, an angle of magnitude theta is equivalent to an angle of magnitude theta plus 2 pi, since 2 pi is equal to 360 degrees in radians. So this implies that trigonometric functions are periodic. That is, they repeat themselves after a certain interval. Sine, cosine, secant, and cosecant repeat themselves after 2 pi. Tangent and cotangent actually repeat themselves even more quickly. So here we're saying that after an interval of length 2 pi, these functions return to where I started. So for example, sine of 2 pi plus pi over 4 is equal to sine of pi over 4, which I know to be sort of spiritually the same as sine of 45 degrees, so 1 over square root 2. In general, you want to get to the point where you're comfortable working entirely with radians, that you don't need to convert pi over 4 to 45 degrees. And then remember that sine of 45 degrees is 1 over square root 2. You want to just in your head know that sine of pi over 4 is 1 over square root 2. So we can use this to actually plot sine of x. So we'll do this in radians. Okay, so what are some values I know? I know that at pi over 4, I'm at the value 1 over square root 2. And in fact, this is what sine looks like. It starts at 0, goes up through 1 over square root 2, hits 1 at pi over 2, and then comes back down. Goes this way, and then comes back up here. So this is one period of sine, one interval from 0 to 2 pi. And then it repeats itself. And it just keeps going forever. And it also repeats itself the other way. So one of the key properties of sine is that it is 2 pi periodic. Cosine is also has this periodicity. The difference is cosine starts at 1, goes down to -1, and then comes back up. So here's one period of cosine. But then again, it continues. So by periodicity, it just keeps going. So I have not discussed how to compute every value on this. And it's not important to know every value. What's important is to know the basic shape of sine and cosine and to understand their periodic nature. Now, tangent is a slightly different beast. It is periodic, as is cotangent, but it repeats itself faster. It repeats itself after a distance of just pi. So the rate at which it repeats itself is more rapid. So let's draw a picture here. So what do I know about tangent? I know that tangent of 0 is 0. Tangent of 30 degrees, which is pi over 6, is 1 over square root 3. Tangent of 45 is 1. Tangent of 60 is positive square root 3. So it's actually getting bigger. So just plotting some values here. So the picture looks something like this. And if I fill it in, actually, tangent looks like this. And it has what in calculus you might call a discontinuity at negative pi over 2 and pi over 2, which means it never actually is able to cross that line. So why is that the case? Well, in that case, you would have division by 0. Because so imagine what a triangle with an angle very close to pi over 2 looks like. So if theta is very close to pi over 2 or 90 degrees, the opposite is going to be much bigger than the adjacent. So their ratio is approaching infinity as theta approaches pi over 2. Again, think of it as I'm allowing the triangle to open up. So the ratio of the opposite leg to the adjacent leg is blowing up. Hence, tangent blows up at pi over 2 and negative pi over 2. We'll discuss in later modules about this asymptotic behavior. But I'll just give a name for this type of behavior now. It's called an asymptote. It's very important for the CLEP exam to have these 3 basic pictures etched in your mind. You want to know basic values like sine, cosine, and tangent at pi over 6 or 30 degrees, pi over 4, 45 degrees, pi over 3, 60 degrees, and then the values at like pi over 2 and pi. And with those and the knowledge of periodicity, you should be able to generate these plots automatically.